Okay, class. Class. Um, the recording has started, so.
Hi, Ari.
And there's a lot of.
Congrats on the stage win!
We're so proud of you back here.
Tennis.
Welcome. We love you.
I should have stuck with tennis.
Okay, so typical Friday. Anyway, so if we could start, one of the things I want to talk about quickly is we're getting into a thing called logarithms, and as intimidating as that may sound, let me just explain how it came to be. Logarithms were actually one of the later inventions of mathematics, which means like 1600s. What happens is that when you have equations like we've been dealing with, exponential equations, y equals 3 to the x, for instance. What's going on here is that oftentimes we can figure out what x is, but there's a lot of times when we have something like y equals 3 to the, 1/2 power. So question is, what does y equal? And the big issue is that we don't really have the ability to deal with exponents because they need to be kind of be brought down to kind of like what I call the ground level of mathematics, the line on the paper. And so what we do is we're going to use logarithms to be able to solve values for x. And actually, I put the wrong value in there to begin with. I should have, as an experiment, what I should have done instead is say, what if I have, oops, sorry.
Damn.
It's more like, what if I said something like 21 equals 3 to the x? That's a better example.
Okay.
So in this case, the typical algebra 1 question, algebra 2 question, solve for x. How do we solve for x? How do we get x by itself? And that's where we're going to be using this thing called logarithms. All right?
Well, you think
So,
challenging for us.
so let's, in logarithms again were created simply to be able to solve for x when x is an exponent. So getting back to our world here, let's go to. So first thing I want to do is let's go ahead and take a look at these questions here, and because we're dealing with exponential questions, anytime we're dealing with exponential equations, we're also dealing with logarithms, right? In this world, in the same way that when we deal with squares, we deal with square roots. We deal with multiplication, we deal with division. In every place you see in math, there's something that math can do, and then something in math that allows you to undo it. So for exponentially functions, the undoing is the logarithm. So we're going to be doing that in a minute, and it's pretty cool stuff. So hang in there. Oh, why is that picture so weird? Okay, so right here, let's go ahead and practice at least getting an understanding of how we solve for x, at least in our head. Any ideas? Okay, so as Will said, he says x is equal to 3. Anyone agree?
Yes.
Now there's two ways that we could have done that. One is you do it in your head. The other one is to look at this as 2 to the x equals 8 is the same as 2 to the third. So once the bases are the same, we can set the exponents equal to each other. Looking at let's look at b.
It's 2.
B, the answer is 2. And there's two ways to do that. We can just look at and think, in our heads, know what it is. Or we could say 3 to the x is equal to what? 3 to the 2 power, right?
Yeah.
Okay? If we could put that phone away, Christina, I would be so much more happy. All right, look at C. C. 4 to the x equals 2. A little trickier.
1/2.
It is 1/2, right? Square root. Another way we could have done that is we could recognize that 4 is 2 squared. Is 2 squared to the x equals 2 to the 1. Right? I'm doing it the long way, obviously, right? So this would be 2 to the 2x equals 2 to the 1 power, and from there we get 2x equals 1, and from there you guys are right, you get x equals 1/2. So 2 different ways of doing it. I like the way you guys just figured it out in your head. That's pretty cool. Let's look at Now, this one, the people in the other class got this one, and I was rather shocked, but
Isn't it 1 5?
what is it? It is 0, right. X equals 0. The weird way to look at this would be to say, it's to say that 5 to the x is equal to 5 to the 0. What does 5 to the 0 equal?
1.
Same thing, right? So, all right. And Megan, let's get off that phone as soon as you can. Okay, x is given here. X is equal to -1, right? And then last one.
1/2.
No,
No.
2/3. 2/3.
It is 2/3, and I have no idea how you would know that. How'd you get that?
Well, because I know that x to the third, or 2 to the third is 8, so you just have to know
Yeah, that's pretty
Yeah.
amazing. All right. So basically, you got, if you go ahead and bring it down to base 2 numbers, it's going to be 3x equals 2. We just set the exponent. Once the bases are the same, we could set the exponents equal to each other, right?
Yeah.
Hello, Mr. Hot. Oh, that's fine. That's fine. Alrighty, no problem. Makes me feel good when my boss forgets his keys too, just like I do. Except I have to ask over there. He always asks. He asks the nice guy though, right? Anyway. Okay, so anyway, before we get into this, I did this. I made this picture and then I cut and pasted it on our plan here. And I want you to look at this picture and I want you to think, if you can remember, what is it about this picture that may remind you of something we did not so long ago? Could you finish that text message and just be done with that phone? There we go. What did we notice? About? Can anyone tell me what the relationship between the red graph and the blue graph are?
They're both the same.
Inverse.
They are inverses. Who said that? Did you say that?
No.
You said that.
I don't talk in this class enough.
Did you say that? All right. The answer is that they're inverses. Inverse graphs, if you remember, are graphs of functions that undo each other. And it's and if you look over here, what are the graphs? One of the graphs is 3 to the x, is the red one, and the other one is log base 3 to the x. And so you notice that it's got, and what's true about the reflection? How do you know that's an inverse graph?
Because
they go
it's
separate ways.
Yeah.
Never.
And we say they're reflected around what line?
The x-axis.
Right. Yeah. So very cool. Isn't that? I don't know. I just think that's really. So now we know.
Marley?
Now we know
Oh.
that these are inverse graphs. And I have a question for you. If this graph has a point, 0, 1. If that graph has a point 0, 1, that means the blue graph has a point what?
0.
1, 0.
Oh, let's go.
Okay, so we go to 1, 1, 0. So whenever we have a graph, it's inverse. All we have to do is do what with the points? We just flip the points. Okay, so moving on. You guys are still with me now? I'm kind of like leading you into some cool ideas. You haven't left me yet? Okay, go to the next. Let's move on to page 2. On page 2, what did I write? It says, in the same way square root is an inverse of squaring, squaring a number, right? Logarithmic functions are the inverse of exponential functions. And so what I want to do is, let's go ahead and do the graph on our own. And so before we do that, we're going to do the graph of the exponential function, in this case, 2x, 2 to the x. And testing our metal with negative exponents. That has got to be like the.
That's 1/4.
Are you writing Megan back with? Okay. Anyway, so x to the -2 is what?
1/4.
1/4. That's so awesome! I can't believe you got that. Anyway,
I know, I'm a genius.
x to the -1.
Just have a test on.
1/2.
1/2. And then 1. And then watch what happens with exponential functions.
It was 2.
2 and then
4.
yeah. Do you guys see? Do you see how the -2 and the 4 are related? Right, they're inverses. Thank you.
Aggregate.
Okay, now the inverse function is called. This is called log base 2 of x. All right, log base 2 of x. So, can you give this to him? A couple of things as we move into logarithmic notation is I want you to know that the word base appears in both. This is base 2 to the x, and then we have down here on the second function we have log base 2 to the x.
But why
So
is it
this
two
is gonna help us when we try to convert from one to the other form. So let's go ahead and find out. Actually, before we solve, let's go ahead and find the points for the bottom. Now, if you look at the inverse function, this function right here, how is this function related to this function? How am I going to? What do I do with the x and y value? That's correct. So what should I put up for x on the top?
Negative 1/4.
1/4, and then here
1/2.
1/2.
1.
Again, 1, 2, 4.
How do you do that on the calculator?
I just did it on paper. Actually, I did it on this little device called Explain Everything.
So you really just flip it.
Wait, what are you saying?
Inverse.
I'm just flipping the numbers, right? Don't worry about your calculator yet. Okay, so let's go ahead and graph these, and let's graph these so we can see if they're inverse graphs.
Oh, they are inverse graphs.
And I bet you they are. So
Whoa.
-2 1/4, -2 1/4. Here's my dot here, and then it's -1 is 1/2.
My answer's quiet.
0 1, 1 2, and 2 4. So there's my first graph.
That's pretty crazy, Mr. Shah.
Tell me about the x-axis on this graph. Do I ever touch it?
No.
No. What is the name? What is the name of the x-axis for this graph?
All x is greater or equal to.
What's that?
All real numbers. All real numbers.
Isn't it our
A
real
Scythian.
numbers?
A Scythian.
Oh, it's
What
an
the
acid-
hell?
It's acetate. Acetate.
Okay. Right.
Yes.
Any line that a graph approaches but never touches is called an asymptote. So in this particular situation, like if we went to -3, it would at x equals -3, it's 1/9. At x equals -4, it's 1/16, and it keeps getting smaller and smaller and smaller, but it doesn't touch the line. So we call it an asymptote. Let's go ahead and graph the other one. And on the other one, what we start with is 1/4. Move positive 1/4 and down -2. So positive 1/4 down -2 is somewhere here. Do you see my blue dot?
Yeah.
And then it goes. The next one is 1/2 -1, and then we get that 1 0 point. 2 1, and then 4 2. And so here's our log graph. I guess you guys in chemistry are dealing with pH is logarithmic, and what that most important thing about logarithmic scales in chemistry is that they're not linear, which means that as you go from 3 to 6, it's not twice as bad. In many cases, it's many times more bad. But anyway, so you got the idea. Again, even though we haven't dealt with logarithms, we know that logarithms are the inverse of exponential functions. Are we still alive? Okay. Let's just go a little bit further before I give you a break.
Boom.
All right.
Take you off.
So.
What I have.
Oh, I'm sorry. I had some questions on the bottom here. I know you changed the page already, but I said just for practice, what are the domains and the ranges? Let's look at the let's do the domain for the black graph first. So the domain for the exponential function, what's it going to be?
All real numbers.
It is going to be all reals. All right, because it takes up the graph itself uses all points to the left and all points to the right. The range will not be the same as that. The range for the first graph, it's going to be greater than 0. All y values greater than 0. Equal to or just greater than? Greater than, that's it.
Oh, I messed
So
up on that.
let's go to the blue graph domain. The blue graph domain is going to be, interesting, it's not all the way left and right, is it?
No, so.
It only goes to great. What is it? X or Y? X is greater than 0, and the range is going to be all reals. Do you see the relationship?
Oh,
Yeah.
yes.
It's as if the domain and the range also inverted themselves, right? Asymptotes. There's two asymptotes. There's the one that I pointed out there, and then where's the other asymptote? The asymptote here is the y equals x. The y equals 1. Sorry about that. The asymptote here is y equals 0. So the y equals 0 is the x-axis. Do you know what the y-axis is called? X equals 0. So the x equals 0 is the other asymptote. What's the name? Asymptote. Okay. All righty. Now we can go to page 2.
The next page.
All right.
Let's do it.
So let's go here. And I think, let me see here. Yeah, we can do it. We're doing well here, guys. So stay calm. Yeah, I'll give you a break in a minute. So, all right. Let's just go to core concept. In this core concept, the basically the idea, and this is kind of a key idea. You guys are so social. Oh, are you actually doing stuff? Wow. Okie dokie. All right. This is the key. If you understand this, most of your homework is going to be fine. Log base b of y, that's what this is called, what I just circled. Log base b of y, that equals x, means the same as b to the x equals y. So what I want you to notice is when we go from logarithmic form to exponential form, the bases are the same, right? Whatever we say base. The other important thing to remember, and this is part of the properties of logarithms, is that whatever the log equals to is the exponent. So you'll notice that the log on the left-hand side, log base b of y equals what? Equals x. X is the exponent. Therefore, it ends up over here. So, see if you can follow this reasoning. I'm going to rewrite this in exponential form. So, the base is going to be 2. The exponent is what?
4.
And that is going to be equal to